Hey everyone, Anthony, and today we're going to look at the progress indicator or progress bars in general for Nuke. Now, so much of our life is spent looking at progress indicators. It seems like a good thing we should poke around with. So what I have on screen here is just a basic rig. I'll go through it in another video. I actually recorded these in the backwards order to which you're going to see them. But suffice it to say that this here, I've replicated a curve tool or a very primitive curve tool in code. It's slow, deliberately slow, accidentally, but it was a happy accident. So when you run this, which I'll do now, so ooh geez, you'll see that I've run it and nothing seems to be happening. So you could guess that Nuke is locked up, and you see the spinning wheel of doom. It hasn't, I know it hasn't, but the response to the user is not very good. It takes some time before any kind of printouts occur. So I'm going to show you the most primitive way you can reassure your user that something's happening, and that's through using the console. By the way, this is not a dockable window. This is just me using OBS to make sure it fits into the right space. So cheating. The console here is pretty much what you'll see when you launch Nuke in Windows. You'll get this thing here, but also if you're in Linux or Mac OS, it should be the terminal you've launched it from. All right. So quickly, the way in which to print, if we print something here, it only goes out here. Right, so we see the output in the script editor. If we want to print something into the console, there are two ways to do it. The first and most obvious way is this, the Nuke tprint command. T stands for terminal, so it prints some stuff to the terminal. And you can see it's not printing here, it's only printing down here. Right, so we can actually just insert that here, nuke.tprint where. For anyone who's used to the idea of Unixy stood in, stood out, stdr kind of stuff, just know that this region is considered sys stood out, standard output. This is considered standard error. So I'll just demonstrate that. If this makes no sense to you, don't worry about it, but just for anyone who does know this stuff, this will help a little bit. Sys stood right, and then stood out. All right, so wait, stdr, oh god, it's confusing. So stdr is printing stuff to both sides. Stood out is here only. It's not doing to both of them. And obviously the print statement prints only going here, and what else? Nuke tprint only goes down here. So there's a couple ways to access it, but won't worry about that too much in detail. So let's just run this again. You notice that this area is still locked up, but there is stuff coming down here. So every time we run through this loop, it's not updating the UI because we haven't whoa, what happened there? That was weird. It's not updating the UI here until everything is done, but it is updating the console periodically. So if you want some more interactive things, you can just use the Nuke tprint statement or sys stood right stuff. So we'll just do that again. Right, so you can still see it coming out in the standard error with the messages here, but it's locked up Nuke. There you go. And then it's printing out here, right? So that's a way you can get more interactivity of a sort. You can update the user and say, hey, by the way, it's going to the farm right now. Nuke is locked up, but it's definitely going to the farm. So that's the first thing. But let's look at something a little bit more friendly. So we'll leave that alone, and we'll get some more space in the script editor. Take this up here. So it's the progress indicator. So let's build one from scratch, and we'll do it explicitly so you can see all the various bits and pieces. So we'll call it a task, a progress task. So you create one this way. You create a progress task and you give it a name. So today's task is to adore some kittens. It comes up and brings in a window. There's a cancel button, some other space. It looks like every other progress indicator you've seen. If you close this, this is not closing the task. This is simply closing the window. So like any other pane, if you close it, this thing still exists. So let me just move my head to the other side. Much better. And then we're going to bring up the progress thing here. So you can see that swallowed that floating window and just brought it up here. So that's all that's happening. Tasks have two key features. You can set a message. So our first step in adoring kittens is locating kittens. And you can see the message comes up here. When you set the first message, it sets a percentage indicator and puts this time to go here, right? So we can update this message a couple times. Locating kittens, listening for meows. All right, you can see now we're listening for meows. What else do we do? Found kittens. And then we're done. All right, so that's just a bunch of messages. We'll use that in a second now. Done. Once you've finished this process, obviously you've located, you want to potentially update your percentage complete at each stage. So let's do that. We start at task, set progress. Now the set progress call accepts numbers from, correctly you give it numbers from 0 to 100. So we'll just do 100 and you can see it jumped to 100, and we can set number at 10. Jumps to 10, so you can go backwards and forwards. If you try numbers greater than 100, it won't do anything. It has no clue here. It's confused as heck. I'll explain that in a second. And if you set negative numbers, it goes to 0. So that's a way to sort of reset this in a fashion. And if you set numbers that are not integers, like 10.2, it will complain at you. It hates them, simply because this is a number from 0 to 100. Yes, you might be 10.2% through, but just give it the number 10. So to do that, you'll want to use one of two functions, int or round. So let me quickly demonstrate. All right, so if I do int of 23.5 and I round 23.5, int will give you 23, round will give you 24. Round as a function, round to even, int fractional bits. So int drops at any 0.5. It doesn't matter if it's 0.9, it'll still give you 23. All right, so you make your call. I'm just going to use int for simplicity's sake in general, but I would probably use round, but not important. So let's task set progress. Oops, we've got one here. So we start at 10, 20, 40, 80, and then 100. So there's our task status. Now I am going to introduce an artificial delay, otherwise, and then, if you just did that, you'll just see it go to the end. So I'm just going to introduce an artificial delay. Import the time module, and the time module has a sleep command, which we're just going to make it sleep for 2 seconds. This is not what I would normally do, but it's quick and it will show the progress of this thing. So let's continue to do that. Note I'm not recreating the task. I'm just mucking around with the progress thing. So let's do that. So you can see 10, import, oh, right, forgot to import time. There you go. So it's 10, 20, 40, and you can see this time to go is being updated. That's not us doing it, well, not directly. That's what Nuke is doing. It's the progress task actually has an internal timing counter. So every time you update this set progress, it goes, oh, you're at 10%. How long did it take you to get to 10%? We'll extrapolate that for the rest of your task. So that's how you can sort of muck around with that one. You can't get to deal with it directly. So that's basically it. And once we're done, the last thing we have to do to the task is we have to, well, close it somehow. So, the way you do it is slightly confusing. You don't tell the you don't do task done, right? Which I can't type. You don't do task done. You actually have to delete the task. Del task. So that's a Python keyword to delete things. And it goes. So this here as a loop is pretty much the core of it. You create the task, you set your progress indicator going, you do some work here at this sleep function, and you keep updating it. When you're done, you just go clear, gone. But obviously you'll notice there's also a cancel button. So let's do that again. Right, come on. There you go. I've managed to cancel it. The sleep locks up the interface, but cancel doesn't do anything. The reason for that is cancel is simply a, let's bring this up again. Task is cancelled. False. Task is cancelled is now unsurprisingly true. Is cancelled is simply telling you the user pressed the cancel button. You as the developer have to decide how to interpret that. Do you stop immediately? Or do you continue to do some work and clean up? Or do you crash Nuke? Or do you ignore the user? All these are valid options for you. Probably don't ignore the user, but the rest of them are quite valid. So to do that, you end up doing things like this. If task is cancelled, then let's do something. So we're just gonna simulate a very hard thing, and we're just gonna raise an exception. Which will, in this case, it will just stop everything working. We'll go through the actual function I have and do it properly, but this, you can see there's a very standardized pattern here. Start doing the task, this is do work here, check your progress. If it's cancelled, you got to do something. You got to stop work somehow, and then you continue that loop. So this is what it looks like now. So we put our status message up here, we do our progress. If the user manages to cancel cancel, then it should stop doing the work. So control is passed back to me, but then we have to also clean up this thing, because the exceptions, like if you run through, it's going to do this line, then this line, then this line, this line. As soon as we get a cancelled, which is just as we found kittens, so I pressed it around about here, it's gone task is cancelled, true, raise an exception. It's stopped here, it hasn't run these lines. And the only way to clean up is this, right? So bear that in mind as the basic pattern we're gonna work with. Right, and we're gonna now go and apply this concept to this function here, which is deliberately slow. So at the beginning, we're gonna start with the task. Task equals nuke progress task. And we're going to do calc max luma pix. Right, so that's what we're saying. We're calculating the maximum luminance pixel. Great. We're going to set the message here. So let's see on the viewer. We go through left to right and we just do it frame by frame, and we do, left to right, scan line by scan line, so scan line by scan line by scan line by scan line, and then frame by frame by frame. So let's just put an update here, somewhat, not at each frame, we'll just so we can see it churning on screen. So we'll do the task, set message. We're no longer locating kittens, we're testing row y equals y. At the end of it, I'm going to finish the task, so we're going to delete it. So you can see task starts here, we delete it at the end here. Testing row. We'll leave out the progress indicator quickly. We'll just do this and see what happens. All right. So you'll notice two things will happen. First of all, I'll make a mistake. There you go. Three things will happen. The first thing I'll do is I'll make a mistake. The second thing is you'll see this churning away like crazy. And you'll also notice that this is now updating along with this down here. They're updating in lockstep, which is actually really nice because and it works. It's really nice because we didn't have that situation before where everything locked up. So this is the lockup situation. Right. So we see still progress occurring here, but I can't do any, you know, that frustration. The reason for this is because by using this progress indicator, this progress task, and there are other ways to do this. I think it's, I can't remember, it's like update UI. This whole interface we're working with in Nuke is Qt based. So you can actually get the Q application and then send it a thing saying, please update the UI. This kind of does it for us. This is Nuke's progress task being told, hey, I've got more information. Please can you draw on screen to tell the user something? And at the same time, it does get a chance to update the rest of the user interface, right? So that'll automatically give you a bit more interactivity. We can take this message here. I'm just going to put it up here. If we have it in this loop, it's going to update less often. So I'll show you what I mean, right? See how I can't select as much. See, it's still a bit sticky, right? It's because we're on, oh geez, oh man, come on, stop it. Right, it's because we only do, this is when this kicks in, it's when we return control to the user interface to update the message on screen, but also to receive user input like me selecting it. We're only doing this once per frame. The time between each frame is relatively long in user interface terms. So you can sort of cheat a little bit by doing this. So see, I've got the same message twice. Let's do that again. And you can see now it feels a lot more, ooh, geez. It's a lot more interactive and snappy because we're giving the interface a lot more time to respond to the user, a lot more opportunities. But equally, we're stealing more time from the calculation process, relatively speaking. So just bear that in mind. What else is the last thing? Oh, that's right. The last thing we obviously have to do is the cancellation thing. So we'll do that again here. Task is cancelled. We'll just leave all that in for interactivity. So we're going to use the same pattern. If task is cancelled, raise the exception. This is going to allow us to, and we're doing it here at the small, let's allow a user to cancel it out here. So every frame they get an we check per frame. So let's run that again. So here I hit cancel. It runs through the rest of the rows before it stops, and it doesn't delete this. We'll do that manually. Get that in a second. If you wanted to cancel immediately, you'd want this cancellation to be down here. So again, part of your design is going to work out how and when you want to cancel. And what do you want to do? Do you need to clean up? For this process, we're simply reading values. It doesn't matter when you cancel it. But if you were running something like a script cleanup process where you wanted to go and fix a bunch of channels or sanitize a bunch of nodes, maybe there's a rogue script that someone's written that's accidentally added a bunch of knobs you don't want, and you need to migrate the data somewhere. You probably want to finish deleting and cleaning up that node you're on instead of hard halting. Right? So let's run that again. So here I can cancel at any time. It immediately stops. Okay. That is kind of the guts of it. The last thing we've got to do is working out how to delete this and clean up after ourselves. Now, this is where it gets a bit messy, unfortunately, the way I've written it. This is my own fault, obviously, because this raising exception will simply stop. It's effectively a hard, whoa, stop right now. Do not execute any more lines. So I'm going to do a very ugly approach to this one. I'm going to try and do all this work here, literally all of it, except we're going to do, I don't know, this is exceptions are, there is good practice with these things. I'm going to pick something that has got more detail than exception. I'm going to cause a, let me get a list of them and pick one. Yeah, I'm going to use stop iteration just as the closest thing. That is kind of what I want to signal. So if the task is cancelled, we just want to stop iteration. So accept for that case. Iteration. Then here we would do our cleanup. Cleanup and anything we want. And I'm going to introduce another thing. We're going to say finally. Del task. That actually... that actually should read fairly cleanly. Try do all of this stuff, except when something has happened, a stop iteration, do some cleanup. The user has obviously, user has hit cancel. So that's the work if the user has hit cancel. And then finally, no matter what happens, make sure you delete the task. So let's run this lot and see what we get. Let's clean up this first. Let's just delete the task. All right, oops. And let's run through this. So here it runs. I got a bit of time to think. Oh God, I've picked 300 frames. Cancel. Right, and it's canceled immediately. So this is kind of how I expect stuff to look when you get into this, just this sort of structure. So I'll just nuke.message, and we'll put a message saying we cancelled. So let's do that again. Cancelled. Whoa, we cancelled it. So that is in a way a complete-ish kind of example. So that hopefully will make sense. But for this, let me break it down a little bit into a more, let's put it down here, into just a pattern you can sort of try use. Now, I'm not saying this is the best way to do it, because this is closer to what happens if you put something in the script editor and just run a script. If this is a function doing work, you'd have to figure out how it works. But let me make this a bit more generic so it looks like a pattern. Make your progress task here. Progress task. Oh, I forgot to do some. We'll do the progress indicator in a sec. I forgot to do that. Try. So you want to set your status. Set the progress. Check if it's cancelled. Right. So we're just gonna get rid of all that one stuff. Maybe output to console. If you want, you might put different things on console otherwise. Except this is check if it's cancelled. If it's cancelled, raise a stop iteration. Signal to user, and then finally clean up the progress. That's all we're really doing here in this kind of structure. So we set the statuses in task, set message, something, task, set progress, 2, 3. If task is cancelled, then in this case raise stop iteration. All right, and then maybe new print stuff. All right, nuke message cancelled. You cancelled, and then so while this here looks kind of scary-ish, and there's a lot of other stuff, it's because it's the work we're doing is making it a bit noisy, right? This is kind of what you're after. You're starting the task, you set a message, you set your progress, check if it's cancelled at whatever appropriate time. You might want to output to the console. Let me change this order actually. Right. There you go. So set your messages, set your progress, output information to the user. Check if someone wants to stop doing something. If, in this case, if someone says they want to stop doing something, we're going to raise a stop iteration. It's a particular choice of how we want to control this. because we're using a try except finally kind of structure. Once we know that someone's giving up on the task, we do some cleanup here. This cleanup can actually reuse the progress indicator and set messages. So you could say task set message cleaning up, and you could have a progress indicator from 0 to 100 for the status of the cleanup. And then this is just bugging the user saying you actually did cancel something. So same principles as this belong here. And then finally, this is the most important thing, delete the task. Make sure every time you create a task, you delete it. There is an exception. It's something you shouldn't use if you can avoid it. It's this. I've created a task. See how the first one has disappeared? Right, still disappeared. It's because of Python's automatic garbage collection. Sorry, how to explain? This progress task is a thing, right? So it's stored in memory somewhere, it's created, and then it's assigned to this variable task. Python's internal garbage collection is just going, well, you have a variable called task, which points to this progress task. I need to reserve that memory for you. I can't throw it away. If I make a new progress task, assign it to the variable task, Python goes, oh, that old memory you pointed at, that old progress task, nothing knows about it. Nothing can touch it. Therefore, maybe you just want to toss it away. Right. So that is why that works. But it's a little bit, you kind of have to reuse that variable. Look up at Python garbage collection and if you're curious, but strongly avoided. Don't rely on that. Always make sure you clean up after yourself and delete it explicitly. So that is, I guess, the guts of it. This is not the simplest thing in the world to get right. If you, for example, this finally, let's just pass. This is most likely the thing you're going to forget to do. It's going to end up like this. Cancelled. Great. Everything works fine, except you still have this thing stuck here. So yeah, that unfortunately stretched out for a bit longer than I thought with me rambling. But this is the guts of how to use the Nuke progress task. It's one of the things that is relatively easy to do to start out with, but it's also relatively easy to leave. You can see I've left garbage here, and I have literally no way to clean this up. You know, and that's not a nice experience, because the longer the session runs for, the more and more garbage, if the code's busted, the more and more garbage will be here, and it's just not nice. So yeah, let us know how you go with it. If this was confusing, please sing out, and I'll strip down the example even more, or go into certain aspects that if you mention what the confusing bits are. But otherwise, enjoy your weekend. I'm going to go back to making feta. See you.